13.5 billion years of silence. No stars, no light, no sound. Just an infinite black ocean of gas, slowly, patiently expanding. And then, James Webb looked directly into that darkness, and it found something that by every rule of physics we've ever written should not have been there. I'm going to show you exactly what Webb found, but I need you to stay with me all the way to the end, because the full picture, the part that genuinely shook the scientific community to its core, I'm saving for the final section of this video, and I promise you it's worth it. Before we go any further, real quick, where in the world are you watching this from right now? Drop your city in the comments. I genuinely love seeing how far this reaches. Okay, let's go. Here's what you need to understand first. For decades, generations of astronomers, the earliest chapter of the universe was completely off-limits. We couldn't see it. Our telescopes weren't powerful enough. The light was too faint, too old, too stretched. That era had a name. Scientists called it the Cosmic Dark Ages, and it was exactly what it sounds like. We always assumed that if we could somehow look back into that darkness, really look, we'd find almost nothing. A few weak, chaotic clouds of gas, maybe the faintest ember of a first-generation star, something humble, something small, something appropriate for a 300-million-year-old universe. We were wrong. Spectacularly, fundamentally, almost embarrassingly wrong. What Webb found instead is rewriting textbooks, and it starts with a tiny red smudge. To understand why this discovery is so disorienting, you have to understand what the early universe was actually like. In the beginning, right after the Big Bang, everything was incomprehensibly hot. Protons, electrons, photons, all crammed together in a dense, blinding plasma. Light couldn't travel anywhere. It just pinballed around endlessly, trapped. The universe wasn't transparent. It was more like the inside of a sun. After about 380,000 years, things finally cooled down enough for electrons to bond with protons. The first hydrogen atoms were born, and for the first time, light was free to move. But here's the problem. All that freshly formed hydrogen spread across the universe as a thick, invisible fog, a fog that swallowed every photon that tried to pass through it. The universe went dark again, almost immediately. This is the era scientists call the Cosmic Dark Ages, hundreds of millions of years, maybe longer, of pure, impenetrable blackness. No stars, no galaxies, just hydrogen, just waiting. Our models predicted a slow, patient ending to this darkness. Gravity, over vast timescales, would begin pulling gas together. Tiny proto-galaxies would form, the very first stars. Massive, volatile, burning hard and fast, would eventually ignite, and their radiation would slowly burn through the hydrogen fog like sunlight burning through morning mist. This process, scientists called it reionization, and they expected it to be gradual, almost leisurely by cosmic standards. Here's what they did not expect: fully formed, chemically complex, blazingly bright galaxies already thriving just 290 million years after the Big Bang. 290 million years. To put that in perspective, the universe right now is 13.8 billion years old. These galaxies existed when the universe was barely 2% of its current age. It's like finding a skyscraper at a construction site that only broke ground last Tuesday. But that's exactly what the James Webb Space Telescope found. And the way it found it tells its own story. Webb isn't just a telescope, it's a time machine. Because light takes time to travel, enormous, staggering amounts of time across cosmic distances, looking at the most distant objects in the universe is identical to looking back in time. The further away something is, the older the light you're seeing. Webb was built specifically for this. Its enormous mirror, its infrared sensitivity, its position far from Earth's atmospheric interference, every design choice was aimed at one goal: to see the light from those very first galaxies. Light that had been traveling for over 13 billion years. Light that the expansion of the universe had stretched all the way into the infrared spectrum. Webb's specialty. So astronomers pointed it at a tiny, nearly empty patch of sky, and they started hunting for red smudges. The JADES program, that stands for JWST Advanced Deep Extragalactic Survey, is one of the most ambitious observing campaigns Webb has ever undertaken. A team of international scientists pooling thousands of hours of telescope time, methodically scanning the deep universe for the earliest light. And in early 2024, they found something that stopped them cold. It was cataloged with the unsexy name JADES GSZ14-0, a tiny, faint red dot, barely distinguishable from noise in the raw data. But when they measured its redshift, the amount by which the expansion of the universe has stretched its light, they got a number that made the room go quiet. That single number placed this galaxy at a distance corresponding to just 290 million years after the Big Bang, a new record, the most distant confirmed galaxy ever observed. They had done it. They'd looked directly into the cosmic dark ages and found a light on. But what that light was illuminating, that's where the story gets strange. JADES GSZ14-0 was not faint. It was not simple. It was not the small, chaotic proto-galaxy every simulation had predicted. It was luminous, shockingly together patiently, stars forming carefully, galaxies assembling over billions of years like a cathedral being built stone by stone. Webb has shown us that the early universe was nothing like that. It was frantic, explosive, overachieving on a scale that our best physics simply cannot currently explain. And here's the part that should genuinely send a chill down your spine. We don't know why. Scientists are now scrambling across multiple fronts to find an explanation. Some are looking at dark matter, the invisible scaffolding that shapes how galaxies form. Maybe the way dark matter collapses in the early universe was fundamentally different from what we assumed. Maybe it moved faster, clumped differently, created the conditions for galaxies to burst into existence almost overnight. Others are looking at the stars themselves. Perhaps the very first generation, called Population 3 stars, were far more massive than anything alive in the universe today. Stars hundreds of times the mass of our Sun, burning through their fuel in just a few million years, seeding their galaxies with heavy elements at a speed we never thought possible. And then there's the wildest idea currently on the table. Dark stars. Hypothetical objects powered not by nuclear fusion, but by the annihilation of dark matter particles in their cores. If they existed, they could shine with extraordinary brightness without producing the chemical signatures we'd expect from ordinary stars, which might explain why some early galaxies look so luminous and yet so chemically strange. These aren't fringe ideas from the margins of science. These are serious, peer-reviewed hypotheses being explored by leading cosmologists right now, because what Webb is showing us has left the mainstream with no comfortable alternative. And the discoveries keep coming.
JADES GSZ14-0 held the distance record for only a matter of months. Astronomers have now confirmed a galaxy called MOM Z14, seen just 280 million years after the Big Bang. And like its